All right, let's jump straight in. If you're running distributed workloads on AWS infrastructure, you already know that squeezing every last drop of performance out of your setup is a constant battle. Welcome to this explainer where we're going to unpack a massive update to Amazon Elastic Kubernetes Service, or EKS. We're diving right into the latest source material from AWS to see exactly how they are giving engineers the tools to fundamentally optimize their clusters. If you've ever felt bottlenecked by network interfaces or kind of frustrated by how your instances are physically placed on the actual hardware, you're definitely going to want to stick around for this. So here's the million-dollar question cloud architects are facing every single day. How do you actually push EKS to its absolute limit? When you're dealing with the raw performance requirements of modern AI training or the massive high availability demands of huge inference tasks, standard configurations just don't cut it anymore. You hit these physical and logical walls. You need a way to orchestrate not just your containers, but the underlying AWS fabric itself to handle these extreme loads. Well, on July 22, 2026, AWS dropped an announcement that completely changes the game for infrastructure scaling with the EKS optimization update. This update basically gives us two massive new pillars natively integrated into dynamic and static capacity node pools. First up, Elastic Fabric Adapter, or EFA, network devices, and second, EC2 placement groups. By bringing these two features directly into EKS Auto Mode and the open-source Carpenter project, AWS is completely eliminating the need for hacky operational workarounds. You can now define these high-level optimizations right at the node pool configuration level. Okay, let's break these down, starting with Section 1, Networking with EFA. If you aren't familiar with it, EFA is a specialized network interface configuration. Think of it as a tool that literally bypasses the traditional operating system networking stack to achieve full interconnect bandwidth. When you're running high-throughput distributed workloads, like, say, training a massive machine learning model where hundreds of nodes need to talk to each other in microseconds, EFA is the thing that prevents your network from choking. It is absolutely the gold standard for node-to-node communication speed. Now, before this update, configuring networking for extreme workloads usually meant eating up your valuable virtual private cloud IP addresses with standard Elastic network interfaces. But now, with Carpenter and EKS Auto Mode, you can choose an EFA-only configuration on capable instances. And here is the real game changer. An EFA-only interface does not consume your VPC IP addresses. This gives you incredibly fine-grained control over your IP utilization, saving your address space, all while maintaining that blistering full interconnect bandwidth. Moving on to Section 2, Physical Instance Distribution. Because, let's be honest, ridiculously fast networking is really only half the battle. You also need control over how your EC2 instances are physically placed across the actual AWS hardware in the data center. Now, you can launch instances using three specific placement group strategies directly from your node pool config. First, the cluster strategy. This packs your instances super close together inside an availability zone. Your goal here is tight grouping for maximum performance and the lowest possible latency. Second is spread. This does the exact opposite, strictly separating your instances across different hardware to ensure high availability. If one rack goes down, your whole cluster doesn't. And third, partition, which creates segmented logical groups across different racks, which is perfect for fault isolation in massive distributed workloads like Hadoop. You just declare the strategy you need, and the automation handles the whole shebang. We've looked at the underlying tech, so let's get into Section 3, the real-world impact. When you combine EFIant networking and physical placement groups, you get this incredibly powerful dual impact on your workloads. For your AI and machine learning teams, you can combine EFI-only networking with the cluster placement strategy to absolutely maximize throughput for those distributed training jobs. Meanwhile, your core backend teams can use the spread or partition strategies to minimize the blast radius for critical production services. You are perfectly tailoring the infrastructure to the specific workload. And yep, these features are available immediately in all AWS regions where EKS is supported. AWS actually summed it up perfectly in their announcement with this quote: "Optimize for the performance, availability, and fault isolation characteristics your workloads require. It's not just about flashy new features, it's about shifting the power back to the engineer. It's about giving you the ultimate fine-grained control to shape your distributed computing environment exactly how it needs to be shaped, dynamically and automatically." Which brings us to our final thought for the day. As automation tools like Carpenter get smarter, now capable of managing physical hardware placement and zero IP cost high bandwidth networking natively, how will your own infrastructure scaling strategy evolve next? If you haven't looked at your node pool configurations recently, this update is absolutely your signal to start experimenting. Thanks for joining me for this explainer. Now go